Hello students, now we are going to discuss 31st problem which is from 2000 AIPMT. A charge Q is situated at the corner of a cube. The electric flux passed through all the 6 faces of the cube is. How to attempt this type of problem? See, it is one cube and you are keeping charge on this point. See, if you want that this charge should be center of a system, you can imagine that you have to put 8 cubes. If you use 8 cubes, then it will come at center. It come at center. It means total charge Q upon epsilon naught will pass through all 8 cubes. So flux related to total flux will pass through 8 cubes. Now it is on center. If you use 8 cubes, it will become at center. And the total flux for that figure, which is according to Gauss law Q upon epsilon naught, will pass through 8 cubes. So per cube will receive the flux Q upon epsilon naught divided by 8. So we will go with option B. Next, it is from 2001 AIPMT. A charge Q microcoulomb is placed at the center of a cube. The flux coming out from each. Now you put the charge at center of the cube. Since it is at center, so it means from all faces equal flux will pass. You keep this at center. You keep the charge at center. It means through each phase equal amount of flux will pass because it is going in all possible direction. And total flux is Q upon epsilon naught. 6 phases are there. So flux related to each phase should be Q upon this. But charge is in microcoulombs. Charge is in microcoulomb. So you can remove that micro with the help of 10 to the power minus 6. So we will go with option A. Next, a charge, it is from 2003 AIPMT. The charge Q is located at the center of a cube. The electric flux through any phase, different exams, question is same, only in this they put microcoulomb. So we have to take care of unit minus 6, we have to write there. In this they are saying charges. Q charge is located at the center. So according to Gauss theorem, flux should be Q upon epsilon naught. They try to make you confuse, but through any phase, total flux is Q upon epsilon naught. So through any phase, it should be Q upon epsilon naught divided by 6, because in cube 6 phases are there, but there where it is written, but they are using 4 by epsilon naught in each denominator. So multiply and divide by 4 pi. So numerator you will get 4 pi q, denominator 4 pi epsilon naught. So denominator 4 pi epsilon naught 6 and numerator 4 pi q. So we will go with B. Next, a square surface of side L meters is in the plane of the paper. A uniform electric field E also is in the plane of the paper, is limited only to the lower half of the square. The electric flux in SI units associated with the surfaces. They asked this problem in 2006. They try fully so that you can score negative marking. You can imagine that whole surface area is L square. They are talking about lower half. So it should be half of L square. You can go like that, but no. See, the square is in the plane of the E, not perpendicular to it. So no flux will incident on your surface normally. It means flux related to your surface is 0. So we are going with option A. Next, a hollow cylinder has a charge q coulomb within it. Phi is the electric flux in units of voltmeter associated with the curved surface. The flux linked with the plane surface A in units of voltmeter will be. They asked this problem in 2007 AIPMT, a very good problem based purely on Gauss theorem. Electric flux are scalar quantity. Just like this, if you have 3 pockets in your pant or shirt and you put 10 rupees in one pocket, 20 rupees in second pocket, 30 rupees in third pocket. Total money associated with you is 30 plus 20 plus 10, 60 rupees, like that. This cylinder has 3 surface areas. One is A, area of cross section of this side, one is B, area of cross section of this side, and one surface area. There are only 3 pockets, 2 circles and 1 curved surface. So all flux is associated with these 3, but they told you that inside this cylinder there is 1 charge q. So according to Gauss theorem, total flux, either it is related with A, or it is related with B, or it is related with C. It should be q upon epsilon naught. Since area of A and C is same, so flux related to A and C should be same. Phi A is equals to phi C. Suppose I am saying this, phi dash, and what they are saying, flux associated with curved surface means phi B is phi. So from equation number 1, what we are getting, phi A and plus phi C means 2 phi dash plus phi, it should be q upon epsilon naught. We want to calculate phi A. It is your target, flux linked with surface A. So we gave it name phi dash. So put phi dash on one side. So we are getting 2 phi dash is equals to q upon epsilon naught minus phi. So what is phi dash? Half q upon epsilon naught minus phi. So where it is given? In A option. So we are going with A. What is the effective capacitance between points X and Y? The figure is given. We want to calculate effective capacitance between point X and Y. We know that we are using Kirchhoff's law in this also, which is the topic of current electricity you studied in 12th class. If P upon Q is equals to R upon S, no need to consider middle one. Same, 6 upon 6 is same, this 6 upon 6 is same, so no need to take this. Current will come from X, it will go from this, it will divide in 2 branch, means like this. This is 6. After this, it will go in this, then towards Y. Like this, it is A, it is C1. After C1, it will pass through it is C3 and it is C2. It is C2 and one current will go through this C3 and after that it will go through C4 and then move towards Y. It is Y. So, these two are in series, these two are in series. So, for these two, for series, if we are taking C capacity of these two C, in series C1 C2 upon C1 plus C2, we got 3. Same for these two, if we are taking C dash, 6 into 6 upon 6 plus 6, we got 3 microfarad. And this combination is in parallel with this combination, means from X, it is 3, it is Y, it is again 3, it is Y. So, these two are in parallel. So, final capacity should be 3 plus 3, 6 microfarad. So, we will go with D option. We will go with D option. Next, it is from 2002 AIPMT. A capacitor of capacity C1 charged up to V volt and then connected to an uncharged capacitor of capacity C2. The final potential difference across each will be, when they are not given, we will consider them parallel. So, total capacity of your system is now C1 plus C2. It is total capacity now. You charge only first conductor, first capacitor. So, it will get a charge according to the rule Q is equals to Vc, Vc1. Now, you join two capacitors, one is charged, one is uncharged. On one there is a charge Vc1, on another there is a charge 0. So, total charge on system is only Vc1. Total charge is what you gave to first Vc1, but total capacity is increased. It is C1 plus C2. So, now potential difference should be V is equals to Q upon C. Formula is this. So, what is charge? Charge is Vc1. What is capacity? C1 plus C2. So, we will go with option Vc1 upon C1 plus C2 means B. Next, it is from 2003 AIPMT. 3 capacitors, each of capacity 4 microfarad, are to be connected in such a way that the effective capacitance should be 6 microfarad. If you connect all in series, you will get 4 by 3. No chance. All in parallel, you will get 12, cancel. 2 in series, so for 2 we will get 4 by 2. 1 in parallel, so we get 2 plus 4, 6. So, we will go with option C, 38C. Next, it is from 2005 AIPMT. A network of 4 capacitors of capacities equal to C1 is C, C2 is 2C, C3 is C3C, C4 is 4C, AP are connected to a battery as shown in the figure. The ratio of the charge on C2 and C4 is C. In your system, C1, C2 and C3, they are in series. What charge is on C1, on C2 and C3 and total all are same. In a series, what is total charge? Individual will get that only. So, if I make these 3 one capacitor, what capacity I will get for these? 1 upon C dash is equals to 1 upon 1 1 upon 2, 1 upon C, 1 upon 2C, 1 upon 3C. It means LCM is 6C, 6, 3, 2. Means 11 upon 6C. So C dash should be 6C upon 11. It means if I am making two capacitors joining these three, I will get a capacity of 6C by 11 and this C4. But these two are in parallel, so potential is same but charge will be different. Both will get same potential, it will get V, it will get V. So charge on this, I am giving this name C. Suppose I am giving a charge to this Q1 and charge on this I am saying Q2. Q is equals to Vc. So what should be Q1? V is V and C is 6C by 11 into V. What is Q2? Capacity of C4 is 4C. Potential is same. They want the ratio of charge C2 and C4. C2 will get same charge. Which combination will get? So Q1 upon Q2 should be our answer. So what answer we are getting? We will cancel out 6C by 11 divided by 4. We are putting 2 2s, 2 3s, and C will also cancel out. So what we are getting? 3 is to 22. So we will go with option B. Next problem is from 2009 AIPMT. 3 capacitors, each of capacitance C and of breakdown voltage V, are joined in series. The capacitance of breakdown voltage of the combination will be, it means what they are saying, you cannot give voltage more than V to any capacitor. Otherwise, the insulation of air will break and whole charge will leak. So maximum voltage which a capacitor can hold is V. If its capacity is C, it is given. We have 3 capacitors. They are joined in series. If they are joined in series, it means what total voltage you will supply, it will divide in 3 parts according to capacity. But capacity of each capacitor is same. In a series, charge is also same. It means they will get equal amount of potential. So if you supply 3 volt, each will receive VVV volt and it can hold V voltage. It is its breakdown voltage. Means up to V it can hold. So breakdown voltage for this system, it is 3V. 3V is given in 2 options. Either C is correct or D is correct. What is the total capacity now since you join in series? 3 has equal capacity, so net capacity should be C by 3. So net capacity is now C by 3 and breakdown voltage is 3V. So we are going with option C. Next, 41. It is from 1995 AIPMT. A 4 microfarad capacitor is charged to 400 volt. If its plates are joined through a resistance of 2 kilo ohm, then heat produced in the resistance is what energy you stored in capacitor that will release in the form of heat energy. So basically we have to calculate what energy we have in our capacitor. So it is half C V square. C is 4 microfarad, not SI unit. Remove that micro. Now it is SI unit. What is V? SI unit only. What is number 444? 64 by 2 means 32. What is the power of 10? Minus 6 and plus 4 minus 2. It means 0.32 joule. So we will go with D option, 0.32 joule. Next, it is from 1996 AIPMT. The energy stored in a capacitor of capacity C and potential V is given by, we know the formula, half CV square. So we will go with option D. Next, it is from 2000 AIPMT. A capacitor is charged with a battery and energy stored is U. After disconnecting battery, I told you disconnecting battery means making Q constant. Another capacitor of same capacity is connected in parallel. Energy stored in each capacitor is, what you did? You disconnect the battery. So total charge, oral question, is constant if initially Q charge was there. So what energy was there? U. You can calculate U by Q square by 2C. Q square by 2C. When you connect two condensers to capacitors parallel, charge will redistribute in the ratio of capacity, since both capacities are same. So Q will divide in two equal parts, Q by 2, Q by 2. So both have now charge Q by 2. Capacity is C. So energy with both should be, now what was the formula? Q square by 2C. But you make Q by 2, it is in term of square. So it will become 1/4. So answer should be U by 4. I am writing what was Q energy initially. In terms of Q, it was Q square by 2C. With each condenser, what energy now associated? Charge will become Q by 2. So its square is Q square by 4. It is from formula 2C. What was in previous case? 1/4 of that means U by 4. So we are going with B. Next, from 1999 AIPMT, a parallel plate condenser with oil between the plates has a capacitance C. If the oil is removed, then capacitance, you know that when you are putting dielectric constant, capacity will increase K times. If you remove, will decrease K times. You are removing, so will decrease 2 times. So if initially it was C, it should be C by 2 now. Next, last problem is from 2006 AIPMT. A parallel plate air capacitor is charged to a certain potential difference. After disconnecting the charging battery means making Q constants, distance between the plates is increased. Distance is increased means you are decreasing the capacity. Potential difference between the plates, you know that what is V? V is Q by C. Q is constant, you are increasing C. You are increasing D means you are decreasing C. You are decreasing C. So ratio will increase. So we will go with option B. So it was the completion of your 9th unit of crash course electrostatics. Thank you.